section 3.3, and our objectives are we are going to, we've been kind of doing this, but for a little bit more official now, we are going to state where the function is increasing, so like the function which is f of x, is increasing or decreasing using the first derivative. And again, we've kind of been doing this other bullet, but we are going to find the max and mins using that first derivative with the increasing, decreasing. So using the first derivative test. Okay? Okay, so let's look at this graph going on. And let's just determine where is this function increasing or decreasing, just so we understand what that means. So this is the function f of x. And here I can see that this function is increasing from negative infinity all the way until negative 3. Then it's going to start decreasing from negative 3 until 0. Then it's going to start increasing again from 0 until 1, 2, 3. And then it's decreasing from 3 and forever. So just kind of talking about that first derivative when we discuss this, what do you notice when a function is increasing? Look at all of the tangent lines. All of the slopes of the tangent lines are positive. And then I have a relative max or min, which we've seen, when that tangent line is going to be 0. Then it switches, and when I'm decreasing, all the slopes of the tangent lines are negative. So basically, if I'm increasing, I know that f prime of x is going to be positive. And if I'm decreasing, I know that f prime of x is going to be negative. Okay, let's look at this one. So let's see, I start out decreasing from negative infinity all the way until negative 2. And then I am increasing from negative 2 all the way until 1. And then I'm just constant from 1 to infinity. So again, when I'm decreasing, all the slopes of those little tangent lines going on are negative. All these slopes are positive, and then constant, I have my slope of 0. Now, if I kind of look, where do these functions change from increasing to decreasing? Well, this would be when the tangent lines have a slope of 0. Oh, what about this one? You can't really have a tangent line here because it's not differentiable. So that's going to be where f prime of x does not exist. And these guys are going to be where f prime of x equals 0. And that's what we've been discussing. These are all critical points of relative max and mins, but they also determine where the graph can change from increasing to decreasing. Okay, just some notation. I'll let you kind of look. And then don't forget, critical numbers are also going to be endpoints if we have them. But endpoints are never relative extrema. They are only absolute extrema. Okay? Okay, so here is basically what we were kind of talking about. So when my first derivative, when the slopes are positive, that's what this is saying. So the tangent slopes are positive, then I know that f is increasing. And here, when f prime of x is less than 0, which would mean that the tangent slopes are negative, then I know that f is decreasing. And when the tangent slopes are 0, then f is going to be a constant. It's neither increasing nor decreasing. So this is our first derivative test. So go find your critical numbers. So find your critical numbers. Okay. Make sure that you are continuous and differentiable. Then I know basically if I have some critical number and f of x goes from increasing to decreasing, then that critical number is going to be a relative max. I also know that f prime of x would go from positive to negative there. And here, if I have some critical number, and f of x is going from decreasing to increasing, then that value is going to be a relative min. And I also know that f prime of x must have went from negative to positive. If I go from increasing to increasing at some critical number, or if f of x does, or if I went from decreasing to decreasing, then I'm going to have a point of inflection at that c instead of a relative max or a min. So point of inflection, if I kind of just recall, it's going to change concavity. So I'm going to go concave down, shaped like a frown, to concave up, shaped like a cup. Or I may go concave up to concave down. So those are points of inflection. Okay, so for AP, to say that you have a relative max or min, you can't, let's put this first, you cannot say that f of x goes from increasing to decreasing, because that's just a given definition, okay? That's just in general. So we can't say that for AP. We have to actually show a little bit more work. This is what we do say. We say that f prime of x goes from positive to negative or negative to positive at some, and then we fill in the x value. Okay, so we fill this in with a specific. Okay, so here are our steps. Find f prime. Find all critical numbers. Then we're going to just have that number line with all of our critical numbers. Then we're going to test in each different piece going on to see if f prime of x is positive or negative. Then we're going to see if I'm positive, then f is going to be increasing, decreasing, increasing, and then I can identify what those critical numbers are. So let's see an example, and maybe that will help. Alright, so find the critical numbers, find the open interval on which the function is increasing or decreasing, and locate all relative extrema. So let's go find our critical numbers, which we've been doing. So critical numbers, remember, are where f prime of x equals 0, f prime of x doesn't exist, and then endpoints, if I have them, but since it only wants relative, I know I'm not even going to include endpoints, and I don't have them. Okay, so f prime of x. And you guys go find your critical numbers. Pause me, got it? Okay, so f prime of x equals dne. We don't have that going on. And endpoints, again, I don't want because I'm looking only for relative extrema. So my only critical numbers are 0 and 4. So now we're going to set up our number line. We have a 0 and a 4. Down here we're going to talk about f prime of x, and up here we'll talk about f of x. So above we're going to be dealing with f of x, and below we're going to be dealing with f prime of x. So I need to pick some numbers that are within those intervals. So -1 is smaller than 0, 1 is between 0 and 4, 5 is bigger than 4. And I'm going to go plug them in to f prime of x and see if I get out a positive or a negative. So -1, plug it into f prime of x. So let's see, that'd be -3 times -5. A negative times a negative is a positive. Let's go find f of 1. That'd be 3 times -3. A positive times a negative is a negative. So you don't actually have to compute everything. You just need to know if they are positive or negative values. Okay, I plug in 5. Oops, that was f prime. And let's see, that would be 15 times 1. That is a positive value. So that's for f prime. So now I'm going to come and I'm going to say, well, if f prime is positive, all the slopes are going up. So I know that I am increasing from -infinity to 0. So f of x is going to be increasing from -infinity all the way until 0. Then, since these slopes are all negative, I'm going to be decreasing from 0 until 4. Then all these slopes are positive, so I'm going to be increasing from 4 until infinity. So then, once I have that, I can pretty much see what's going to be happening. This is going to be a relative max. This is going to be a relative min. Is it an absolute max? Think about this graph. This graph went here, here, here of some sort. So is this going to be a relative or an absolute max? Well, since other values go higher, it's only relative. So just a little note, this is not absolute.